Hey guys, this is Funday TV presenting you a session on probability distribution. So in this session we will be discussing the questions. In case you want to learn the basics, do watch the first session on probability distribution. So first we want to give you a master clue that will help you solve all the probability distribution questions. Yes guys, so if you just concentrate on 2 points, you can solve any probability distribution question. Okay, so first thing, so in any given question you have to identify what the random variable is. Okay, so for example, consider that you are rolling a die. Okay, so what is the random variable and what values can the random variable assume? In that case, the random variable can assume values like 1, 2, 3, 4, 5 or 6, right? So if x is the random variable which is a result of the experiment of rolling the die, then these are the values that x can assume, right? So you have to identify the random variable while solving any probability distribution. So this is the first task. Second thing is, you have to draw the probability distribution table for the different values of the random variable. Okay, so like consider this example, rolling of a die. Okay, so what is the probability that x will assume the value 1? It's 1 by 6. Similarly, what's the probability that x will assume the value 2? It will again be 1 by 6, right? So like that, probability that x will assume the value 6, again that will be 1 by 6, right? So you have to draw a probability distribution table, right? Probability distribution table means the values that x can assume and the corresponding probabilities for that particular value, right? So here if you see, so this is the probability distribution table that we are talking about. Okay, now once you would have computed this probability distribution table, all that you need to do is find x square into p of x to find the variance, and to find the mean, what you'll have to do is you will have to find the value of x into p of x and then sum up those values. Like 1 into 0.1 will be 0.1, 2 into 0.3 will be 0.6, 3 into 0.45 will be 1.35, 4 into 1.15 will be 0.6. So you sum up those values and the result will be the mean. Okay, and once you get the mean, you take the square, you take the square of the random of the values of the random variable, you multiply it with the corresponding probabilities, sum them up, you get the first term of the variance, subtract the square of the mean value, you get the variance. So it's that simple. Okay, so all essentially the crux is you have to arrive at the probability distribution table. So moving on to the questions. So find the mean, variance and standard deviation of the number of heads when 3 coins are tossed. Okay, so when 3 coins are tossed, these are the possible outcomes, right? So these 8 outcomes are there when the coin is tossed. Okay, and you have to find the mean, variance and standard deviation of the number of heads. Okay, so what could be the number of heads here? It could be 0, like the case here. It could be 1, 1, 2, 1, 2, 2 or 3, right? So the number of heads could be 0, it could be 1, 2 or 3. Okay, so what you'll have to do is arrive at the probability distribution table for p of x equal to 0, for p of x equal to 1, likewise x equal to 2 and x equal to 3. Okay, so let's move on. So these are the possible outcomes that the random variable can assume, and these would be the corresponding probabilities. Y 1 by 8 for for P of X equal to 0, because there is just one occurrence TTT out of all the 8 occurrences. So this will be 1 by 8. Likewise, Y 3 by 8 for P of X equal to 1, because you have 1, 2 and 3, that is 3 values out of 8. Similarly, 3 values out of 8 for P of X equal to 2, and 3 and 1 out of 8 for P of X equal to 3. Okay, so these probability tell us that the probability that the number of heads would be 0 is 1 by 8, probability that the number of heads is 1 is 3 by 8, and the probability that the number of heads is 2 is again 3 by 8, and the probability that the number of heads is 3 will be 1 by 8. Okay, so once you arrive at these two, your job is done. Okay, let me tell you, once you arrive at these two things, your job is done. All you have to do is multiply these two, you get xi into pi, take the sum, this will be the mean value, square the random variable, multiply it with the probability, sum it up, subtract the square of the mean like the formula here, that is 3 minus 1.5 square, or this would be 3 minus 2.25, or this would be 0.75. So this will be the variance, and this is what we got here. This is the mean which we got. Take the square root of the variance, that is square root of 0.75, you get the standard deviation. Okay, so all you have to do is draw this probability distribution table. Let's move on to the next question. So a die is tossed once if the random variable x is defined as x equal to 1, if the die results in an even number, and x equal to 0 if the die results in an odd number. Then find the mean and the variance of x. Okay, so when a die is rolled, you take x to be 1 or 0. 1 if the die results in 2, 4 or 6. 0 if the die results in 1, 3 or 5. So what is the probability of x equal to 1? That is 3 outcomes, 2, 4, 6 out of 6, which will be 1 by 2. Similarly, the probability for x equal to 2 will also be 1 by 2. So you'll have the probability distribution table ready for you. X can take values 0 and 1, and the corresponding P of I will be 1 by 2 and 1 by 2. Okay, so moving on. Let's solve this question again. So this is a probability distribution table. We multiply xi and pi, we sum them up, we get the mean. Take the square of the random variable, multiply it with the probability, sum it up, subtract from the square of the mean, that is 0.5 minus 0.5 square, to get 0.25. This will be the variance or sigma square for you. Okay, you take the square root of variance, that is square root of 0.25, and you get the value of sigma. Okay, which will be the standard deviation. So it's that simple. Okay, let's move on to the next question now. So two cards are drawn simultaneously from a well shuffled pack of 52 cards. Okay, so out of 52 cards, you're drawing 2 cards. Okay, find the mean and the variance of the number of aces. Okay, so when you're drawing 2 cards, those cards could be both of them as aces. Those cards could be like, the first one is an ace, the second one is not an ace. The cards could be like both of them are non-aces, right? So the number of aces could be 0 or 1 or 2. So this would be my random variable. Okay, So if x is my random variable, it could take values as 0, 1 or 2. And you would have to find what is the probability that no ace is drawn, what is the probability that one ace is drawn, what is the probability that two aces are drawn. So the probability that no aces are drawn will be when you will be, so how many aces are there in a pack of 52 cards? 4, right? So there are 48 non-aces, right? There are 48 non-aces. So out of those 48 non-aces, you draw 2, and the probability will be 48C2 by 52C2. Why 52C2? Because you're drawing 2 cards out of 52. Probability of x equal to 1 will mean you're drawing one ace out of the 4 and you're drawing a non-ace out of the remaining 48. What is P of x equal to 2? That is the probability of drawing 2 aces will be when you'll be drawing 2 aces out of 4 and you'll be drawing 2 aces out of the, you'll subtract it by the total number of ways in which you can select 2 cards. That's 52C2. Okay, so this way you can form the probability distribution table. So you got the probability when no aces are drawn, it's 188 by 221. Probability that when one ace is drawn is 32 by 221, and the probability that when two aces are drawn, it's 1 by 221. Okay, you multiply these two values, so you have the probability distribution table. Now you multiply these two, sum them up, you get this value. Again, it's 0 plus 32 by 221 plus 2 by 221. So this is what gives you 0.15. So this will be the mean value. You arrived at the mean. You take the square of the random variable, multiply it with the probability. Again, you sum it up, and then you get 0.16. You subtract the square of the mean value, and you get the variance, that's 0.14. So this will be the variance. Take the square root of the variance and you get the standard deviation. Okay, so moving on to the next question now. So this time around, 3 defective bulbs are mixed with 7 good ones. Okay, let x be the number of defective bulbs when 3 bulbs are drawn at random. Okay, so you're drawing out 3 bulbs, okay, at random. So you have to find the mean and the variance of x. What is x here? X is the number of defective bulbs. Okay, so when you're drawing out when you're actually drawing out, say, 3 bulbs, okay, when you're drawing out 3 bulbs, it could be that none of them are defective. It could be that one is defective and 2 are non-defective. So in this case, none of them are defective and 3 of them are non-defective. Sorry, yeah, none of them are defective and 3 of them are non-defective. So in the second case, one of them could be defective, 2 could be non-defective. Likewise, 2 of them could be defective, 1 could be non-defective, 3 could be defective, 1 could be non-defective. Okay, so the values for the random variable would be 0, 1, 2, 3 and 4. Means that the probability that no defective bulbs are drawn is P of x equal to 0, which you'll have to find out. Similarly, you'll have to find out P of x equal to 1, probability that one bulb is defective, probability that 2 bulbs are defective, and the probability that 3 bulbs are defective. Okay, let's move on. So this is what we got. So probability that no bulbs are defective, it's 7 by 24. How come we got 7 by 24? Because you are drawing 3 bulbs, 3 non-defective bulbs out of 7 bulbs, and total number of ways in which you can draw 3 bulbs is 10C3. So 7C3 by 10C3 will give you So that will give you 7 into 6 into 5 by 3 into 2 into 1 multiplied by 10 into 9 into 8 by 3 into 2 into 1. Okay, so you solve this. So these cancel out. Similarly, these will cancel out, cancel this, and you get 7 by 24. Okay, so that's what P of x equal to 0 means, that you are drawing no defective bulb. So when you're drawing one defective bulb, it could be, the probability would be, see, you are drawing one defective bulb out of 3, and the remaining 2 would have to be drawn from non-defective bulbs. You divide it by the total number of ways, you get the probability, that will be 21 by 40. Similarly, P of x equal to 2 would be 3C2, that is, you're drawing out 2 defective out of 3 defective bulbs. You multiply it with 7C1, you divide it by 10C3. Similarly, P of x equal to 3 will be 3C3, all 3 of them are defective. You won't select anything from non-defective bulbs, divided by the total number of ways. Okay, so you'll get this value as 1 by 120, and you'll get this value as 7 by 40. Okay, so once you have the probability distribution table in place, all you have to do is multiply these two, xi and pi, sum them up, get the value of the mean, take the square of the random variable, multiply it with the probability, sum it up, that is 1.3, subtract the square of the mean value, you get the variance, that will be 0.49. Take the square root of 0.49, you get the standard deviation. Okay, so all you again needed to do was to arrive at this probability distribution table. Okay, and in case you have not understood what P of x equal to 0 is, what P of x equal to 1 is, let's go through them again. So P of x equal to 0 means that no defective bulb is drawn. Okay, so out of the 3 defective bulbs, you're not drawing out any defective bulbs. Okay, so out of the remaining 7, you're drawing out 3, divided by the total number of ways, you get the probability of x equal to 0. Okay, likewise, P of x equal to 1 means that one defective bulb is drawn out of 3, so that will be 3C1, and remaining 2 bulbs have to be drawn from the 7 non-defective bulbs, so that will be 3C1 into 7C2 by 10C3. Okay, so this way you arrive at the probability distribution table, and then it's just about applying the formula to get the mean, standard deviation and variance. Okay, so last question. So in a game, 3 coins are tossed. Okay, again 3 coins are tossed. A person is paid ₹5 if he gets all heads or all tails, and he is supposed to pay ₹3 if he gets 1 head or 2 heads. Okay, so what can he expect to win on an average? So means you have to find the mean. Okay, so a person is paid ₹5 if he gets all heads or all tails. So what is the probability that you have all heads or all tails? So that would be equal to the number of ways in which you can draw out all heads or all tails, that's 2, divided by the total number of ways, that will be 8, so that will be 1 by 4. Similarly, the probability that you have 1 head or 2 heads will be equal to, so all these 6 cases, that will be 6 by 8 or else 3 by 4. Okay, so you now know the probabilities, you now know the probability distribution table. What will be what values will the random variable x assume here? It could assume the value 5 or -3, right? Why 5 or -3? Because that's the value that the person is going to pay. Okay, so for paying 5 the probability is 1 by 4, and for paying -3 the probability is 3 by 4. Okay, so we just, once we arrive at the probability distribution table, we just multiply the values of xi and pi to and then add them up to get the mean value. Take the square of the random variable, multiply it with the probability, add it up to get the value of xi square into pi, and then you'll have to subtract it from the square of the mean to get the variance. But anyways, variance is not required here. All we have to find is what the person can expect to win on an average. Okay, so on an average he can expect to win the mean value, that is coming out to be -1. Okay, so -1 means that the person is expected to actually pay ₹1, okay, in the game. So he will be paying out ₹1. This minus sign indicates that he will be paying that ₹1. Okay, so don't get confused about it. So that would be all for now in probability distribution. So in case you want to revisit, so we'll go back to the first slide, and in the first slide, so all we did was what we did in the first slide, right? So in the first slide we talked about drawing the probability distribution table, and that's what has helped us. Finding out the probability is something that you know now, right? Because we have discussed it in our previous sessions. Okay, so you just have to find the random variable, the values for that random variable, and then you have to draw the probability distribution table. Okay, so that would be it for now. Okay, we'll meet up again. Thank you so much. Have a great day. Thanks from Fundy TV.